Solve the problems on finding the Z transform of some basic signals using properties. The first problem is x of n is equal to u of minus n. Second problem is x of n is equal to n into u of n. Third one is x of n is equal to minus n into u of minus n minus 1. Fourth is x of n is equal to n into a to the power of n into u of n. Fifth one is x of n is equal to minus n into a to the power of n into u of minus n minus 1. That is, all these problems we need to solve using the properties. That is, first problem is x of n is equal to u of minus n. Okay, that is, we can write that let x1 of n is equal to u of n. Then this x of n can be expressed as x of n is equal to x1 of minus n. Using time reversal property, we can write this one as x of z is equal to x1 of 1 by z, because time reversal property says that x of n z transformation is x of z, x of minus n z transformation is x of 1 by z. Okay. Now, what is x1 of z here? What x1 of z is equal to summation of n tends from 0 to infinity u of n, its value is 1, into z to the power of minus n, that is summation of n tends from 0 to infinity z to the power of minus 1 whole to the power of n, that is x1 of z is equal to 1 divided by 1 minus z inverse. Okay. Now, to get x of z, z should be replaced by 1 by z in this equation. That is, put z is equal to 1 by z in this equation. That is, x1 of 1 by z is equal to, it is nothing but x of z. It is 1 divided by 1 minus 1 by z whole to the power of minus 1. We get 1 divided by 1 minus z. Okay, this is the z transformation of u of minus n. Okay. Next, the second problem, x of n is equal to n into u of n. This property we can solve it using the differentiation in z domain property. What is the differentiation in z domain property? X of n, its z transformation is x of z, where n into x of n, its z transformation is minus z into differentiation of x of z. Okay, that is, here in this, let us take that x1 of n is equal to x1 of n is equal to u of n. Okay, then you can write that x of n equals to n into x1 of n. This is, but using differentiation in z domain property, we can write this as x of z is equal to minus z differentiation of x1 of z. What is x1 of z here is, that is, this is the x1 of n. x1 of z is equal to summation of n tends from 0 to infinity u of n value is 1 into z to the power of minus n, that is summation of n tends from 0 to infinity z to the power of minus 1 whole to the power of n, that is x1 of z equals to x1 of z is equal to, you get 1 divided by 1 minus z inverse. We know that z transformation of unit step function is 1 divided by 1 minus z inverse. Since we need to differentiate this, let us express that in terms of positive power of z. It is x1 of z equals to 1 divided by 1 minus z inverse can be written as, you can take this as 1 by z, that is z divided by z minus 1. Z is the LCM here. Denominator of the denominator goes to numerator. It will become z divided by z minus 1. Now, what is x of z? X of z is equal to minus z into differentiation of x of z with respect to dz. That is, x of z equals to minus z differentiation of, that is z divided by z minus 1. That is, you get x of z is equal to minus z. This differentiation is z minus 1, its whole square, z minus 1. Differentiation of numerator is 1 minus z. Differentiation of denominator is 1. Okay, that is x of z is equal to minus z. You can write this is z minus 1 minus z whole divided by z minus 1 its whole square. This z and this z is get cancelled. that is minus 1 into minus z, it will become plus z divided by z minus 1 whole square. This is the x of z. You can express this as a negative power of z, that is, if you take z common here, it will become, that is, z divided by z square, that is 1 minus z inverse its whole square. One z is get cancelled. When this z goes to numerator, it will become z to the power of minus 1 whole divided by 1 minus z inverse its whole square. Okay. Now from this you can draw the conclusion that when input is n into u of n, its z transformation is z inverse divided by 1 minus z inverse its whole square. When you have this, when they give it, when this is very much useful when you are doing the inverse z transformation. When you have the x of z is z inverse divided by 1 minus z inverse whole square, its inverse z transformation is n into u of n. Now we go for the next problem, that is third problem is x of n equals to minus n into u of minus n minus 1. Okay. Now let us take this, that is, let this also we can do it using differentiation in z domain property. Let x1 of n is equal to, let us, u of minus n minus 1. Let us keep this minus sign as it is. Okay. Then we'll get x of n is equal to minus n into x1 of n. Then its x of z is given by using minus sign, you keep it outside as it is, n into x1 of n. Using differentiation in z domain property, you can write that, that is minus z into differentiation of x1 of z. You will get, that is, x of z has minus of minus will become plus here, z into differentiation of x1 of z with respect to dz. Then what is the differentiation of x1 of n here? That is that is z transformation of x1 of n here, that is x1 of z is equal to, that is u of minus n minus 1 is there. This exists from minus 1 to minus infinity, and the summation range is n tends from minus 1 to minus infinity. U of minus n minus 1 value is 1 into z to the power of minus n. That is summation of n tends from minus 1 to minus infinity z to the power of minus n. In this equation, put n is equal to minus n. You will get x1 of z equals to n tends from 1 to infinity z to the power of n. It will become 1 divided by, sorry, z divided by, using the formula we can write z divided by 1 minus z. Okay. Put this in this equation, you get x of z. X of z is equal to z into differentiation of z divided by 1 minus z. This is z, you keep it as it is. Differentiation of z divided by 1 minus z is 1 divided by 1 minus z whole square. 1 minus denominator, keep it as it is. Differentiation of numerator is 1 minus numerator. Differentiation of denominator is minus 1. That is, you'll get z into 1 minus z. Minus of minus will become plus z whole divided by 1 minus z its whole square. This z and this z is get cancelled. It will become z divided by 1 minus z its whole square. Okay. You can express this as a negative power of z. X of z is equal to, that is, z divided by, you can take z, that is minus z common here, that is z is common, that is, it will become z square. It will become z to the power of minus 2. So z to the power of minus 1 its whole square. This one is get cancelled. You can write, that is, z to the power of minus 1 divided by z to the power of minus 1 whole square can be written as 1 minus z inverse its whole square. Okay. That means when you have a negative sequence, that is left-sided sequence, its the transformation is z to the power of minus 1 divided by 1 minus z in whole square, and the input is minus n into u of minus n minus 1. Okay, this is useful when solving the inverse z transformation. Hence, from this you can draw the conclusion that when the input sequence is n into u of minus n minus 1, its z transformation is z inverse divided by 1 minus z inverse its whole square. When they give this x as x of z, its time domain sequence is minus n into u of minus n minus 1. Okay. Okay. So the next problem, that is x of n is equal to n into a to the power of n into u of n. Okay. Now let us take that. Let this problem also we are solving it by differentiation in z domain property. Let x1 of n is equal to a to the power of n into u of n. Then x of n equals to n into x1 of n. Okay. Using differentiation in z domain property, we can write that x of z is equal to minus z into differentiation of x of z with respect to dz. Okay, what is x1 of z here? Is x1 of z is equal to summation of n tends from 0 to infinity. Because of u of n, we are taking the range from 0 to infinity. A to the power of n, u of n value is 1 into z to the power of minus n. This is summation of n tends from 0 to infinity, a into z inverse whole to the power of n. Okay, then this can be written as 1 divided by 1 minus a z inverse, where a z inverse is less than 1. Okay, now this we have to express this here for negative power of z as a positive power of z. This is z divided by z minus a. Substitute this x1 of z in this equation. You'll get x of z is equal to minus z differentiation of x of z, that is z divided by z minus a. Okay, you will get that is x of z is equal to minus z denominator, that is z minus a its whole square, z minus a into differentiation of z is 1 minus denominator denominator differentiation of numerator minus numerator and differentiation of denominator is 1 here. You get that is minus z minus a minus z divided by z minus a its whole square. This z and this z is get cancelled. Minus a into minus z, it will become az divided by z minus a its whole square. Okay. Now again this can be written as az, as it is. The denominator, let's take z common, it will become z square, that is 1 minus a z inverse its whole square get cancelled. We get x of z is equal to az divided by z square into 1 minus a z inverse its whole square. This and that is get cancelled. X of z is equal to a into z inverse. This z you take it to the numerator, it will become 1 minus a z inverse its whole to 1 minus a z inverse its whole square. Okay, this is the answer. This is x of z. That means from this you can draw the conclusion that when input sequence is n into a to the power of n into u of n, and its z transformation is a z inverse whole divided by 1 minus a z inverse whole square. Okay, go for the fifth problem. The fifth problem here is, that is x of n is equal to minus n into a to the power of n into u of minus n minus 1. Okay, let us take, let x1 of n is equal to a to the power of n into u of minus n minus 1. Then I'll get, that is x of n equals to minus n x1 of n. Okay, let's keep that minus n as it is. It is x of z is equal to minus n, you keep it as it is. The z transformation of n into x1 of n is, that is minus z differentiation of x1 of z whole divided by dz. This answer is, that is z minus of minus will become plus, that is z into differentiation of x1 of z with respect to dz. Now what is x1 of z here? That is x1 of z is equal to summation of n times 1, because x1 of n is a to the power of n into u of minus n minus 1. Because of this u of minus n minus 1, summation range is minus 1 to minus infinity a to the power of n. This value is 1 into z to the power of minus n. In this equation, put n is equal to minus n. You get x1 of z is equal to summation of n times from, when n is minus 1, it will become 1 to infinity a to the power of minus n into z to the power of n. It will become, that is summation of n times from 1 to infinity a inverse z its whole to the power of n. Then answer is x1 of z is equal to, that is a inverse z divided by 1 minus a inverse z, minus a inverse z. This is the x1 of z. Substitute x1 of z in this equation. That is, we get x of z. X of z is equal to z into differentiation of x1 of z is a inverse z divided by 1 minus a inverse z. You get, that is x of z is equal to z into, here we have, that is differentiation of a inverse z divided by 1 minus a inverse z. Okay, that is z into 1 minus a inverse z its whole square, 1 minus a inverse z, denominator, differentiation of numerator is a inverse minus a inverse z, numerator, the differentiation of denominator is minus a inverse. Okay, then you will get z, you have a inverse minus a to the power of minus 2z minus, this is minus into minus will become plus a to the power of minus 2 into z whole divided by 1 minus a inverse z its whole square. Okay, this term and this term get cancelled. You get a inverse z divided by 1 minus a inverse z its whole square. Okay, this is the x of z. Okay, here let us take z common. You get x of z is equal to a inverse z divided by, when you take z common, it will become z square outside, it will become z to the power of minus 1 sorry a z inverse z to the power of minus 1 minus a inverse its whole square. Okay, otherwise we can take a as in a inverse z is also common, it will become, that is a to the power of minus 2 z square will get outside, this will become, that is a into z minus 1 in that. Okay, now this term, this means get cancelled, and when a goes to new, it will become, that is a to the power of 2 a z inverse divided by, I can take minus common here, it will become 1 minus a z inverse its whole square. This is the x of z. Okay, now from this problem we can draw the conclusion that if input is minus n into a to the power of n into u of minus n minus 1, then its z transformation is a z inverse whole divided by 1 minus a z inverse its whole square. This is very much useful when you are solving the inverse Z transformation problems. When you have an x of z, a into z inverse divided by 1 minus a z inverse whole square, then its inverse Z transformation is minus n into a to the power of n into u of minus n minus 1. Okay. When you have a left-handed sequence, we have to express that in terms of u of minus n minus 1. When you have a right-sided sequence, you should express that in terms of u of n.